In this lesson, we'll talk about the combustion of hydrocarbons. And remember, when we say hydrocarbons, we really mean fossil fuels. And fossil fuels include gasoline, coal, and natural gas. During the combustion of hydrocarbons, it can undergo two forms of combustion. The first form is complete combustion, when there's a lot of oxygen present. And the product of complete combustion is carbon dioxide and water vapor. If there is a lack of oxygen available, hydrocarbon will undergo incomplete combustion. And then you can have a lot of different products forming, including carbon monoxide, just plain carbon or soot, some CO2, and of course energy. And both of these reactions are exothermic, which means they release energy, in this case in the form of heat energy. It turns out it is really difficult to ensure that hydrocarbons are combusted completely. Even in the presence of a lot of oxygen, there is still a slight percentage of incomplete combustion happening. However, as more oxygen is present in the combustion chamber, there is less incomplete combustion and more complete combustion. Even though incomplete combustion occurs in a small amount always, it is possible to reduce the percentage of incomplete combustion by increasing the amount of oxygen available. There are two ways to notice if complete combustion is occurring. If you see a yellow flame or a lot of light, it means that soot is being formed and the hydrocarbon is being incompletely combusted. On the opposite side, if you see a very clear blue flame, such as the flame you should see in a furnace or a fireplace, you would see that it is completely combusted. Therefore, blue flame is good, yellow flame is bad. If you ever see yellow flame in your furnace, you should have that fixed immediately because that is a sign of an incomplete combustion and carbon monoxide is being produced. Carbon monoxide is very toxic to humans because it will reduce your blood's ability to carry oxygen. Carbon monoxide is very toxic because its shape resembles that of oxygen. It can bind to hemoglobin very well and prevents oxygen molecules from binding in your hemoglobin. Therefore, if enough hemoglobin is bound with carbon monoxide, there is not enough hemoglobin for your body to carry oxygen to your cells. Carbon monoxide can build up in confined areas such as garages or inside houses if there is a source of combustions such as from a furnace, a stove, or a car nearby. Atmospheric concentration of carbon monoxide can also be reduced by making sure that plenty of oxygen is available for combustion. Besides oxygen from the air, oxygen can be added to gasoline in the form of alcohol. Alcohols are called oxygen generators because they provide additional carbon atoms within the fuel for combustion. In fact, some race cars only use methanol as their fuel instead of gasoline because the proportion of oxygen to carbon is much higher in methanol than regular gasoline. If they burn methanol, they can completely burn all the fuel and release all of the energy present in their fuel. Let's compare ethane and ethanol and look at their oxygen content. In this balance equation for the combustion of ethane, you see that there is 3.5 moles of O2 is required to burn every 1 mole of ethane. However, in ethanol, only 3 moles of oxygen is required to burn 1 mole of ethane. So we can see that it is more easy to completely combust ethanol than ethane, so that there is less carbon monoxide produced. In the combustion of hydrocarbons, a lot of carbon dioxide is formed. Remember, carbon dioxide is a greenhouse gas, and the accumulation of greenhouse gas has been attributed to global warming or climate change. All of the carbon dioxide serves as a blanket and traps the heat that's radiated back from the Earth. The heat cannot escape into space and is retained on Earth, and the climate of the Earth will eventually change. We'll complete the petition project case study in order to figure out the effect and the causes of climate change and what man can do to reduce climate change.